So let me just focus the correct screen there. Okay, so as mentioned, my name is Bramus. I'm a front-end developer from Belgium. I also do backend and some things in between, but my main focus nowadays is JavaScript and React. However, my love for CSS, progressive enhancement and things like that, it will never die. In my spare time, I like to go scuba diving. So if you're a scuba diver, hit me up on Twitter. But I also run a blog. It's named bram.us, and on there I collect interesting links to like small articles or videos that somebody else has posted. But I also write my own content on there. So I have two categories elsewhere, which are the links in the videos, and then original content, which are the full posts. You should check it out or follow it on Twitter. The handle is @bramusblog. RSS is also available if you're a fan of that. I am. So let's take a look at the ECMAScript timeline. There's a few interesting things to see here. Now, what stands out there is because I added an image on there, is that ES4 never happened. But what I find more interesting is like this little cut that you can make, because before 2015, we had these irregular release intervals. We had ES1, 2, 3, 4, 5, and so forth. Well, 4 didn't happen, but then after after 2015, we have these yearly releases and the numbering changed. So it wasn't ES7, 8, 9, or 10. No, it was the year it was included in the release name. So what happened there? Well, before 2015, the strategy was like, okay, we want features X, Y, and Z. We want that in our release. Let's build. And once we have all those features, let's ship a new version. Now that didn't really scale because between ES3 and ES5, there were 10 years, quite a long time. So the strategy changed. After 2015, it was like, okay, let's just develop some features. And at the end of each year, let's take a look at which features are complete. Those that are complete, we will include these in the yearly specification. Those that have not been finished yet, we'll just include them next year or even the year after if needed. So who does that? Who decides doing that? Well, it's TC39. TC39, TC stands for Technical Committee, and 39 is just a number. And they are the committee that is burdened with the task of evolving and maintaining the ECMAScript language. ECMAScript, I say, yes, this is not a mistake. ECMAScript is the official name of the general purpose cross-platform programming language. And then JavaScript is an implementation of ECMAScript. If you remember ActionScript from back in the day, kind of the same story. ActionScript was inspired upon or was an implementation of the ECMAScript specification. The members of TC39, well, they are certain companies, including, of course, implementers, which are the browsers, but also other companies who are heavily invested in JavaScript. There are representatives in TC39 from PayPal, Facebook, Boku, Igalia. They all have representatives in there. What do they do? Well, the TC39, they have meetings every 2 months. They come together and everything is shared online. And during those meetings, they try to evolve all the proposals using a certain development process. The cool thing is, right now, today, there's a meeting going on. So it started 2 days ago and it lasts until tomorrow officially. But there's a TC39 meeting going on right now, and they are doing things using that development process. What does it look like, the development process? Well, a development process, it's a 5-stage process by which they evolve the specification or the definition of ECMAScript. And it looks like this. We have stage 0 on the left and then stage 4 on the right. And the goal is, if you have a JavaScript language proposal, an ECMAScript language proposal, you start at stage 0, and it has to evolve through stage 4 before it gets included into the specification. Now, hot off the press, these stages, they also have names, like stage 0 is straw person, stage 3 is candidate. Yesterday at the meeting, they decided to drop those names. So they will only be talking about stage 0, 1, 2, 3, and 4. By the way, you can see that they are programmers because they start at 0, index 0 programming thing. So the stages, let me just give you a quick overview. So the stage 0, this is the straw person stage, or there was a straw person stage, and it's like a concept stage. If you have an idea for a language feature for ECMAScript, you can write it down like on a piece of napkin or on a small piece of paper and just send it over to be in stage 0. That's like the big pool of wild ideas And from that, TC39, they will pick some and move them over to stage 1. When do they do that? Well, this is basically them signaling like, okay, we kind of like this idea, we're gonna consider it, and then it becomes part of stage 1. So what do you need to do for that? Well, you have to not just write everything on an napkin. You have to give a little bit of an API overview, some examples, describe what the problem solves, but not very, very broad, just a basic description of everything. And major changes here are still allowed. At this moment too, TC39, they pick a champion, that's a member of TC39, who will be the driving force behind the proposal. Stage 2 is a draft stage. For your proposal to make it in there, TC39 basically says okay, we seem to be onto something, let's develop it. And then your proposal can become part of stage 2. Now you need to have a formal description in there, not a loose description. You have to precisely describe everything in there. And also they expect an experimental implementation. Now, this is quite interesting because experimental implementation, it can be in Babel, but also in browsers. So you can have stage 2 features which are not finalized at all, already to be shipped in browsers. Now, mostly they put them behind feature flags and things like that, but I think it's really nice. And stage 3 is the candidate stage. At this stage, TC39 considers the proposal to be finished. So they say okay, everything is specced out, but they want feedback from implementers. So those are the browsers, but also external feedback, which is us users. They basically want to verify okay, the thing that we described here, will the internet break or won't it break? If all goes well, the internet doesn't break, JavaScript keeps on running on every computer, on every website, then your stage will advance to, your proposal will advance to stage 4, which is the finished stage. And then it's ready to be included into the standard. So here we have our 5 stages. Do note that proposals can be withdrawn. So a proposal can make it into stage 2 and then be dropped. This can be in favor for a new proposal, or 2 proposals can get merged or things like that. Or a better proposal is being proposed, and then the other one is being suppressed. And it's only those that make it into stage 4 which get included into the next ECMAScript yearly release. When is that? Well, in January, they take a look at the meeting. What are all the proposals that are into stage 4? Okay, these are new, we will include them into the yearly release. Then they have to update the spec and include all the things. And then by July, the ECMAScript General Assembly, they approve the final text and release it. So ES2021, that's fairly recent. It was only officialized, I think, this early July or something like that. So it's really, really new. Now, do know it's not because a feature is in stage 4 that you can't use it already. Because if you remember, if I go back a little bit, it's stage 3, which is the candidate stage, which already has support in browsers and Babel and other things like that. So for us developers, stage 3 is the most important stage, because then we know okay, this feature is really, really gonna make it into the specification if nothing breaks. So that was a whole explanation to explain this code. By the way, you see ES6 there at the 2015, just right before the line. That one got renamed to ES2015. So now it's always ES2015, 16, 17, 18, 19, 20, and ES2021. Woohoo! So let's take a look at a few of my favorite proposals or my favorite features. So I always be showing you the stage it is in at the top right there. So here we have field declarations, which is stage 3. Field declarations, I kind of like this one. So let's rewind time back. How do we have a data member on a JavaScript class? So we have this .click count there, you see there. How do we define it? Well, in ES2015, if you have a class and you want to add a default in there or take it from a constructor, you have to do it into the constructor. There you have to set this .click count equals 0. With public fields, that has changed. Public fields is a proposal that already has shipped. It's already stage 4. Public fields say okay, we don't want the constructor thing. We just want to define the click count onto the class directly. It looks like this. So here we define this .click count with a default value of 0. If you're familiar with Java or PHP or things like that, this looks kind of nice, right? Now, what about private fields? How does that work? Well, private fields, you might think, oh, I know, we use the underscore for it. Well, no, that's still public. Because using the underscore, that was just an agreement between developers. We are saying like, hey, if it's prefixed with an underscore, don't use it publicly. But there's no real code preventing you from using it publicly. So they had to settle on another prefix. You could have used the private keyword, but the TC39, they settled on the pound or the hash. Now, do note this is not a hashtag, so this is not hashtag click count. It reads as the private field click count with a default value of 0. One thing I don't really like in there is when we are using it, like in the increment function you see there, you also have to include the hash. It's for several technical reasons, so that's how we need to do it. Cool thing, this is stage 3. It landed in Firefox 90, which was released 4 days ago or something like that. So you already have support for this in Firefox 90, and I think Chrome already supports it out of the box. Cool. Stage 3, so this one will really definitely make it into ES2022 perhaps. Optional chaining. This is a feature from ES2020, but I want to cover it for you because it has changed the way that I write my JavaScript code. So let's start with an example object that we have here. We have a message, and it has a user and a content, and then for the user we have the first name, the location, and the Twitter handle. So let's select something from there, and we'll use console.log to show it into the console. Let's select something that exists. For example, first name. Well, the output of this message.user.firstname, that's of course the value that was in there, Bramus, so no worries there. Now, let's select something that doesn't exist. For example, a last name that doesn't exist here. What do we get back here? Well, here JavaScript will tell us, hey, this is undefined. And that's true because last name does not exist on the user object. Now, let's select something inexistent, but with a fallback value. Like, okay, say that if there's no last name, let's use a fallback value instead. Well, we can use short circuit logic for this. So we have message.user.lastname or anonymous. So if the thing on the left evaluates to something that is falsy, like a 0 or undefined or null, things like that, we will have the value on the right, which is anonymous. So this thing right here outputs anonymous. Kind of nice. But now let's select something inexistent with a fallback value. So let's select message.meta.publication date and fall back to the current date. Now do notice message.meta does not exist on there. And then we try to read publication date from message.meta. What will we get back here? Well, it's not undefined. We will get back cannot read property publication date of undefined. We'll get back an error. Whoa, why is that? Well, it's actually correct because the publication date of undefined, that undefined that you see there, that is referring to message.meta. Message.meta is undefined, so it cannot read the property publication date from it. So this is the problem that we have here. How can we solve this? Well, there are some hacks that you can use. You can short circuit the whole thing using short circuit logic. You can fall back to empty objects every time. Very nasty hack. Please don't use it. But we have a proper solution nowadays with ES2020, which is the optional chaining operator, and the code looks like this. So we have message question mark period meta question mark period publication date. That's the optional chaining operator used in there. And this one here actually outputs today's date. Well, this was generated a few days ago, so it's not today's date or the actual date, but it should do the date when you run this into the JavaScript console. So this is really nice. How does the optional chaining operator work? Well, here is a formal description. If the operand at the left-hand side of the optional chaining operator evaluates to undefined or null, the whole expression evaluates to undefined. So if you have the rule there at the bottom, we take a look at this optional chaining operator, and then we check the definition. Well, the thing on the left, does it evaluate to null or undefined? Message, no, that one exists. So message, no, it exists. So we go back to the otherwise value, said, oh, the target property access method or function call is triggered normally. So we try to read something from message. Then we go back to the next optional chaining operator. Again, we check the thing on the left, message.meta. Does that evaluate to undefined or null? This is the case right here. It evaluates to undefined. So the whole expression evaluates to undefined, the whole expression being the whole thing which is highlighted right here. So we get back undefined or new date to ISO string, which gets executed, and then we get back today's date. So this here is a summarizing slide. At the top again, you see at the top right again, you see the stage it is in, or the ECMAScript release it is in. And at the bottom there, you see a small link. No worries, I will post the slides online afterwards. I will put them on Twitter, on my blog. I will put them on video too. So no worries there, you can check it out afterwards. I kind of like this one, optional chaining operator. It has really changed the way I code, especially when combined with another operator. But first, this one quick warning though. The optional chaining operator is it's spelled question mark period. So it's not just the question mark, it's the question mark and the period, which allows you to like dynamically access functions. At the very last line, you see there, name of the function, question mark period. So if the function is defined, then it will be executed with the arguments there. Really, really nice. Now this optional chaining operator, it becomes really, really, really powerful when combined with null coalescing or nullish coalescing. So let's take another object here. We have a message with some settings on there, and then we have a show splash screen value of false. So let's select some stuff for the default value in a safe way, hey, using the optional chaining operator and a small fallback value. So we have message.settings.show splash screen or true. Well, what do we get back here? Well, we get back true. Now, this is not really what we want, because if we check the value for show splash screen, it is actually defined, and it's explicitly defined to be false. But yeah, if you have an expression that says false or true, you get back true in JavaScript. So that's a problem. Well, how can we solve this? The nullish coalescing operator. It looks like this. It's a double question mark that you see there. And this one will actually output false. How does it work, this operator? The null coalescing operator serves an equality check against null values, null or undefined. So we have it there. We check show splash screen. Is that null or undefined? If that is the case, you go back to the thing on the right of it. If that is not the case, which it is here because show splash screen is false, then we will take back the original thing that we wanted to fetch. So we get false, the operator, and then true. This one results into false. Again, summarizing slide with the link there. So these two optional chaining, null coalescing, they have really changed the way how I code my JavaScript, and I suggest you use it too. It's a real time saver and lots of code saver. The less code I can type, the better. So let's take a look at some other example, some other proposals. Logical assignment. This one was released in ES2021. Browser support is really, really good. Take a look here at this line. You have options.foo equals options.foo, or if that's not defined or set, then we fall back to the value far. Now, the value bar. Now this works here, but there's a problem. We always trigger a setter because we either set options.foo into options.foo, or we set bar into options.foo. So we always write something back into memory. We don't really want it. We could rewrite it as this. This feels like really, really wrong to type. So we have if options.bar is that null or undefined, then set the value to cox being there. Kind of weird to type. My mind can't cope with this. So what is the solution? Well, the solution is a logical assignment operator, and it looks like this. Options.foo, the double question mark equals bar or crux. And that will basically say like, hey, if options.foo on the left is that thing null or undefined, if that is the case, okay, we're going to write the value bar into there. It also works with or and with and. So we have only assign if A is falsy, which is the mallet operator. You might know it using that from another programming language. Only assign if A is truthy, so that's with the double ampersand, and then only assign if A is null or undefined. Cool feature, I like this. By the way, if your browser doesn't support this, you can use Babel for that and pre-transpile your code so that it uses a fallback code. I will talk about it a bit later. Dynamic importing, this one made it into ES2020, which is lazy loading for your JavaScript modules. Say you have a lightbox that you want to show. So you have a photo on a web page, you click on it, and then you want to show the page into a lightbox, so full screen, you can move between the images. Well, you could import the lightbox at the very top of your code, but then the problem is, well, as long as you don't use the lightbox, you're just loading unnecessary code. You're shipping unnecessary code to the user. So what does dynamic import allow you to do? It allows you to take this import and then import it when you need it. Using the await keyword. So we have an async function, asynchronic function with the await keyword. So when we click on the link, it will wait, first load the lightbox, and only then it will show the lightbox. Kind of like this. By the way, talking about lazy loading images and iframes is totally possible in HTML nowadays. So you don't need any JavaScript for this any longer. The only thing that you need to do is add the loading attribute on there and give it the value of lazy. We also have eager and auto. Eager, which means like load it right away, and then auto, well, the browser kind of decides like when it has time, it will try and load the image. So lazy loading images and iframes, that's a native feature nowadays. Cool, right? Decimal, let's do some math. Let's count to 0.3. This is stage 1, so it's really new, but they are working on it. If we add 0.1 to 0.2, what do we get back as a result? Well, we don't get back 0.3. No. We get back 0.300000004. Oh no, JavaScript is broken. Well, JavaScript is not broken. It's not only JavaScript, by the way. It's a problem with floating point math. It has something to do with computers and how they store numbers. So if you go to this wonderful website, 0.30004.com, you get a whole explanation about it. So this problem, it exists in PHP too, in other programming language. It's everywhere. It has to do with how computers work. So we have this problem right here that we have 0.30004 and so forth. We only want 0.3. How can we solve this? Well, decimal will solve this for us. It's a new type, so we have integer, float, string, and things like that. Well, decimal, it will be a new type, and it has the suffix m. So 0.1m plus 0.1m, so the decimal 0.1 plus the decimal 0.2 equals the decimal 0.3. You might be wondering, oh, why the m suffix? Why not the d? Well, the problem is that the d is part of hex code, and then yeah, it could like trip up things somewhere. So they decided to use m as the suffix. There's also lots of work going on there, like to allow adding decimals to integers and things like that, and automatic conversion. So that will be taken care of. Stage 1, I really want this feature, especially if you're doing something like a shopping cart where you are calculating values and things like that. I would like to see it there. The cancellation API, stage 1. Now, if you've ever worked with promises, there's this problem. So here we have a promise that we can call, like we can do something async with it, and then after 2.5 seconds, it will resolve. So we call it, and then 2.5 seconds later, we get back promise resolved. So it's okay, this is nice, this works. But what if we want to cancel the promise? Like for example, if we navigate away from the page, we don't want this promise to do anything anymore. So if you call the promise and we navigate away immediately, we actually want to cancel this promise being called. Well, there's no real way to do that in JavaScript nowadays. How can we do that? Well, the cancellation API, and it looks like this. It's a bit of a big code, but I'll walk you through it. So the first thing that we do is we pass in a cancellation token into our function that does something async that returns a promise. This could also be an async function, by the way. So we pass in a cancellation token. The first thing that we do in our function body is we check like, hey, is the cancellation token, is it already being asked to get cancelled? If that's the case, we just stop right here. The second thing we do is we register a callback. So when it is being cancelled, the request is being made to cancel it, we register this callback. So here what we do there is we reject our promise. And then at the very end, right before we resolve our original promise, we unregister our registration that we did before. So you pass in the cancellation token checks, do I need to stop right here or not? If that's not the case, it will wait for a call being made to it. So how does it work? How can you use it? Well, we have this cancellation token source instance that we create right here. We pass it into our function that returns the promise, but then we also set a timeout. for 1 second. So our promise, it lasted 2.5 seconds, but we cancel after 1 second. So we get back promise started, and then after 1 second, source.cancel is being called, and we get back promise.called. This is really, really nice. A typical example would be like a find as you type kind of thing, like a live search. So if you type something, yes, I know you could debounce it and throttle it, but you can also do like just do the request, and by the time you type in another character, you cancel the previous request. I think perhaps a combination of both, like throttling and using the cancellation tokens, that would be a best practice. One side note with this, you might have heard about the abort controller. Like, oh, but I know how to cancel a promise, or I know how to cancel set timeout. You can use the abort controller. Yes, that's true, but this is not a part of the ECMAScript definition. This is a browser feature. This is a vendor-specific solution that was implemented in browsers. I would like to see something land in the ECMAScript specification instead of the abort controller. String not replace all. This is really, really, really new. ES2021. We all know, we've all been there. If you have a string and you want to replace a character, what does it do? Well, it only replaces the first character that it finds. So you get back the quick brown fox, so that O gets replaced, but dog doesn't get replaced. So how do we fix this? Well, we have to use a regular expression. Regular expressions. That works, but it's kind of a hack. So what did they add to the ECMAScript specification? Replace all, and it does the job for us. Small addition, huge impact. I like it. Declarations and conditionals. Stage 1, really new, but I like where this is headed. So here you can see in our code, we have 2 checks for food up data. So first we get food up data, and later on we read food up data again. So that's 2 reads. How can we optimize this? Well, we could optimize this by declaring data beforehand. So there we read food up data, and then we use that one. That works. What the declarations and conditionals feature allows us to do is like to have this definition right inside of the if. So we move it into the if, and there we check. We don't do an equality check here, by the way. So here we check like, okay, if food up data, if that one exists, we store it into the data variable, and then later on in our for loop we use the data variable. Kind of cool. Temporal. This is for you, for every one of you who has ever worked with dates in JavaScript. It is horrible. That is because the date API in JavaScript, it was one of the first APIs that landed into JavaScript at the very beginning. I think it was even in ES1, perhaps ES3. I think it was ES1. But it was inspired, it was a direct copy from the Java API. So they took over the entire signature from the Java API, but that one was really, really, really crummy. The temporal API, this is something that should fix it for us. It's a more modern datetime API. So if you're using external libraries, you will to like work with dates, you will soon be able to replace it with temporal. Still stage 3 because it's stuck somewhere. It needs a certain extra definition or a thing to be defined, and once that is done, it can move to stage 4. The specification, what it does is, or the feature, what it does, it has a distinction that it makes between instance and then date times. So an instant, that is always a date time that it creates regarding with respect to UTC. So it's expressed in UTC. It's always calculated against the epoch. So it's January 1st, 1970. Then you have the plain date time ISO strings, or the plain date time. That one is the date and time expressed in the time zone of the user. So you have it there, but then the time zone information itself is not included in there. If you want to have the time zone information included in there, then you have to use the zoned date time instance to make that work. So the last one there, it does include the time zone information. There are some functions, of course, to like convert between an instant to a zoned date time and vice versa. That always works. And there are also some cool things that you can do there. So for example, we can create a zoned date time instance from a certain string. Then we can do some calculations with that, add some certain hours, change the time zone to another time zone, and then get back the toString. So that works really, really nice. Quite a difficult API to understand, but once it clicks, it will work out. Really, really cool stuff. They have great documentation too. The link is there at the bottom. Oh, these here are some slides that shouldn't be in there. Let me just skip that. Yes, all right, here I want to be. Slice notation, small addition that will make it up. Say we have an array and we want to like chop a piece from it. We want to slice from it. We use object.slice with the start index and an end index. Well, a new language feature that's being proposed is this small syntax that we say like, okay, we want array, we want indices 1, 2, 3 included. We want that back. I like it. But it's also cool that it also works on strings. Well, if it ever gets into stage 4, it will also work on strings. So you can get back substrings from strings very, very easily. Cool. And then pattern matching. I think this is one of the last proposals that I want to show you. Perhaps there's another one following, but pattern matching is a really, really cool one. Say that we have a vector, so this is not pattern, this is manual pattern matching. Say that we have a vector, so you can have a 2D vector or a 3D vector, like a 3-dimensional vector, x, y, and z. To calculate the length from such a vector, you have to use a certain formula. So if it has an x, y, and z in there, you have to use this formula. If you have an x and y in there, you have to use another formula. If it has a length, just return the length, and otherwise return an unknown vector type. So this is the manual thing, but what you basically want to do is like you want to look at the shape of the object. Does it have the x, y, and z? Then do this. Does it have the x and y? Then do that. And pattern matching allows us to do that. It looks like this. So it says match the vector, and when there's an x, y, and z in there, use this certain formula. When there's an x and y in there, use another formula, or when it's spreadable, return the vector.length. So this is kind of like this. The syntax has changed because it's been stuck in stage 1 for quite a long time. They are still talking about it, but I hope this one really makes it into ECMAScript. Why is that? Well, it will be very, very handy when doing fetches. If you fetch something from a resource, then you can check the contents of there. Like, okay, if there's a status 200 in there, then do something. If the status is 404, then do something else. Just by looking at the shape of the object, of the response that you get there. Kind of like this feature. I hope it will ever make sense. And this was just a selection, folks. There's lots and lots of more things to talk about. There are many, many features that are coming to ECMAScript, and they are all being talked about, all in the open. So you can check it out at TC39 GitHub, the proposals. And you can also check the agendas, by the way. You can have a list of the stage 0 proposals, the finished proposals, all kind of things. Really highly interesting stuff to follow if that's your thing. I also write some things from there on my blog. It's bram.us. And I also have this direct link to a certain category there. So ESNext, welcome to the world of tomorrow. These are all features that will be there. Well, some are today, but mainly tomorrow. But actually, they're already here today because we have, remember, stage 3 is the most important stage. So we have things like Babel, which already has implementations. And also we have certain features that first land in browsers before they get officially formalized and make it into stage 4. I want to thank you for your time. My name is Bramus. I also run a blog. It's bram.us.